All right, got a little bit to this. Now let's add friction. So remember, Newton's laws, force diagrams. When you're doing them, remember, direction, 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 please. Left will be negative, right will be positive. So we get this situation, draw it out. We know for this, it's going to be going down or to the right in every case. Unless friction stops it, but either it's not moving or it's going. So there's our M1, M2. They're coupled, they're connected with a string or rope. You got your tension. So now if we consider friction, we just have one extra thing. Here's the non-friction case. Okay. Now we will do the friction case. So different color. If we look at mass 2, it's being pulled down by gravity. When we get this, it's going to be that way. So force of gravity, then tension, then on this one, tension is that way because the same force stays in there. There's no bends or anything in the string, no change in force throughout, it's uniform. Then if we're moving this way, because this thing's coming down, friction is against the direction of motion. So force of friction, I'll put this down here so you can see it better. And I'll make it uniform on this side. Tension, force of friction, tension, gravity, gravitation. And so we will have, let's say we're given M1. We're going to kind of like before, let's say 8 and 2. Coefficient of friction, make it 0.1. All right, we're not on an inclined plane, so we don't have to do any trig, sine, or cosine with this. Otherwise, we'd have to. But the force of friction is like the normal force. Remember, and this will be kinetic because it'll be moving. I'm not going to do static and kinetic. I'm just going to tell you it's moving. Let's do kinetic. Make it easier first. Okay, the thing's moving, kinetic. Let's go with that, and not see if it's going to start. So we'll just pretend it's that kinetic friction. Simplify things at first. We got V sub k times the normal force, and remember F sub n. It could be in IB speak, that's an R. Okay. Capital N for normal force, F sub n, R. Different letter for the same thing. So then we got that. We know the tension. Fg is just mg. And so now, if we do our Newton's law thing with this one, we got tension to the right, so it's positive, minus the force of friction is M1A. Here, we got the weight, force of gravity, minus tension is M sub 2 times acceleration. Net force is MA. Net force is MA, right there. Then, if we do the thing before, we can put the two equations together, rewrite this, switch these out. Add them together, t's cancel out. Then factor out the a, divide by m1 plus m2 as we did before. Same concept, just review the video. A, m1, or force of gravity minus force of friction over m1 plus m2. So force of gravity is mg. So fg minus t is in that. What is that? Putting here, added, got that, divided. Okay, f sub g is, I should have put a 2. Whoops, but we got the idea. M sub 2, of course. That's what it's for. And so m sub 2 times g, and this will be like that, which will be b sub k times mg. So this will be m2 g minus b sub k m1 g over m1 plus m2. Okay, so similar to before, we've got this little correction factor, and then if we solve it as before, m2 g b sub k m1 g. All right, erase this part, then I'll rewrite this, then do a problem. So our acceleration will be our formula. If we factor the g out, m sub 2 minus b sub k m1 over m1 plus m2 g dun, 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 dun. Okay, then plug in our numbers, clean this up. So we got, with our new formula, then of course we change tension. Just go back and plug this into an acceleration in one of the things and get a tension formula. But acceleration will be 2 minus 0.1 times 8 over 2 plus 8 times 9.8. Then I'll put this in parentheses, make sure we're trying to help some people, some folks might get confused. You're tired, you don't rewrite 0.1. So 0.1 times 8 is 0.8. 2 minus 0.8 is 1.2. 1.2 over 10. I'll write it out, make sure people are clear. So A equals 2 minus 0.8 over 10 times 9.8. A equals 1.2 over 10 times 9.8. Then that's going to be 0.12. 0.12 times 9.8. 1.18 approximately. computer screen, don't go dark, please. There. There we go. All right. So there's one with friction on the table. So a little addition to what we did before. Of our analysis, we got our formula. So that's a generalization that applies to every situation like that. Know your formula, plug and chug. All right, now on to some other videos about this stuff.